Hi, my name is Hangtung, and in my group, we have Wisney and Arnoldus. For our main project, we plan to work on iStick, and we throughout the slides we will be giving informations on the sensors that we're going to use and some other important materials. Hope you guys enjoy. So, our project main summary is that there are many blind people on Earth, and each one face different difficulties in their um, everyday life. Out of the many difficulties they might have, our group intend to work on the project called iStick, or you can call it Smart Kings, which will help our blind brothers and sisters solve some of their problems. Of course, we can make an iStick that can solve all the problems, but out of the many problems that they might have, we intend to focus on some um, situation areas, and and for our project, the main situations that we intend to solve is to warn them obstacles that are nearby and in front of them, notify them the moisture level of the ground they are walking on, because although sometimes although at first we were thinking about to detect only waters, um, floors can get wet too, and which can be very dangerous. So we intend to focus on the moisture level instead of just detecting water, and tell the blind person their location if they desire to know. Meaning, if they press a certain button, they would be able to hear from the headset um, their approximate location. The
System design overview. These are the main parts of our system. A proposed system will use a microcontroller for handling data and sensors. A 9-volt rechargeable battery will provide power for the system. It's going to have a set of specialized sensors, a set of buttons for user input, a Bluetooth module for wireless connection to a phone, a motor to provide feedback to the user, and a buzzer to provide feedback as well. As you can see, this is the basic graph of the system diagram that I'll be going in deeper in the next slide. As you can see from the schematic on the right, um, the core of the system will be a microcontroller, and we chose to use Arduino Nano that we got provided. The microcontroller is going to have input devices like moisture sensor for sensing water, um, set of buttons for user input, ultrasonic sensor for obstacles, light sensor for sensing the light and turning on LEDs for safety, and Bluetooth module for communication with an external device, which is probably going to be a phone, as well as output devices. Output devices are buzzer and motor for alerting users of dangers, and Bluetooth module, which can act as input or output for communicating with external device, a phone. System functionality. The system that I was talking about, uh, with all its components, shall detect obstacles, detect water or wet floor, make a sound and vibrate when obstacle or wet floor is detected, connect to a cell phone via Bluetooth and exchange information, and use phone's GPS service to provide information about user's current location through an auditory response. Safety and usability of our system. The usability requirements for our system are that system shall warn the user of an obstacle, water, or wet floor by vibrating and sounding the buzzer. System shall give directions to or from certain locations using GPS from the phone. System shall be lightweight and easy to grip for easy handling, and system shall operate without charging for at least 48 hours. In addition to usability requirements, we have system requirements, which are that the system shall be weather and water resistant. System shall not cause interference with any other devices equipped by the user. And system packaging shall be sturdy and drop resistant. Subsystem design and implementation. The project consists of several subsystems, and each project member has certain subsystems assigned to them. And this assignment of tasks are based on the member's strengths and knowledge in certain area. While some of the subsystems were tested during component testing and calibration, others weren't. And some other systems that we have are still in design stage and have not yet been tested and calibrated. The first subsystem that, and probably the most important that I'll be talking about, is a Bluetooth transceiver. Bluetooth transceiver is used to exchange data between Arduino controller and user's device, which is most likely going to be a cell phone. The part name that we chose is called HC-05, although this selection is not yet finalized. This Bluetooth transceiver will allow the sensor information to be sent from the controller to the cell phone. The cell phone will be used to issue auditory responses and also information about location and other. Potential challenges of Bluetooth transceiver. The known potential challenges are that we need to make an advanced algorithm for this data transfer that is going to deal with GPS and other sensor logic, and also making the Bluetooth module compatible with most mobile operating systems, which there are three main ones. And also unknown potential challenges, which are that we have no prior knowledge with Bluetooth interfacing, and we still have to fully understand capabilities and limitations of this Bluetooth device. Next is moisture or humidity sensor. Moisture sensor will be used to detect moist areas and alert the user to use caution. Sensor will be mounted at the very tip of the cane, and the sensor shall be able to detect water and or moisture on the ground. In case of moisture reaching a certain threshold by detecting water or moisture, auditory signal will be produced, um, while the data can optionally be sent to the phone for further processing. The sensor that we chose as our humidity sensor is called SEN-13763. There are several potential challenges that pertains to our moisture or humidity sensor. The first challenge being is that moisture and humidity are not always a good indication of wet floor, and rather can just be indication of that it's very humid outside. So another sensor might be needed for water detection on the ground. Also, if the sensor resides in an enclosed compartment within our device, reading of the values might be inaccurate and can be completely invalid.
The One of the sensors that we intend to use for our project is the ultrasonic sensor. The ultrasonic sensor will measure the distance or present of a target object material through air without touching the target object. And we will have a certain feed to detect to. Also, the measured distance is given as an output in a variety of standard electrical interfaces compatible with display, which how the that's how the ultrasonic detects an obstacle, which the ultrasonic sensor will be connect to a microcontroller. For our project, the purpose of using the ultrasonic will be that it will be the one to detect obstacles so that the blind person can know if there's any obstacles in front of the blind person. And most likely we will be using the HC SRO4 ultrasonic sensor provided by the school, provided by FAU, unless we find a much better one. The ultrasonic sensor, there will be some challenges when working on it, and but there are also some helpful resources. So for the some of the challenges are connecting the ultrasonic sensor to the eye stick so that it won't fall no matter how hard the stick is being moved would be challenging because most likely the person using it will be moving the stick a lot, and if the ultrasonic is not placed it perfectly, there might be very big chance of falling it, and making it detect the exact feed that we intend to work on. That wouldn't be a really challenge, but you never know. So it's better to be prepared for it and not underestimate it. And but codes are pretty much available online for the ultrasonic sensor, which is really helpful. So also a buzzer sensor will be used for the project, which a buzzer is just an audio device that signals, and a buzzer will be used in our project to make noise for different occasions. For example, when it detects an obstacle, it will make a noise so that the blind person can be alarmed, and the buzzer will be used for many more other reasons for this project. Um, we are not sure yet which exact buzzer we will be using, but for now it will look something like in the picture. Hope that helped. Some challenges when working with the buzzer sensor will be connecting the buzzer to a button and making a sound will be challenging because the wires will have to be put in correctly, and sometimes working with wires can be a little difficult when it doesn't expect when it doesn't work as you anticipated. And making the buzzer to sound and vibrate, which um, will be another challenge. And implementing codes for the buzzer, most likely, or if we are lucky, we might find a buzzer codes for the Arduino. But if we can't find one, we will have to write a code for it, and which can be a challenge.
One of the sensors we're going to be using in our system is a GL55 series photoresistor. The GL55 series photoresistor is a light-sensitive variable resistor. We're gonna use this sensor as a on and off switch for a LED light. The light will be a warning light for other pedestrians. The sensor will be independent from the whole system, so you're gonna be using only the battery and the nighttime and daytime. So at nighttime the light will be on, and daytime the light will be off. Another component we'll be using is the micro vibration motor modules. This component uses a small amount of current and voltage. The very small vibration motor will be used as an obstacle and wet flow warning. So the way it'll be working is when the ultrasonic sensor feels there's an obstacle 7 feet ahead, it will send a signal back to the microcontroller, and the microcontroller will turn on the micro vibration motors. The same thing with the moisture sensor. When the moisture sensor senses some water on the floor, it will send a signal back to the microcontroller, and the microcontroller will turn on the small vibrator motor. So the vibrator will vibrate, and then the person who carry this stick will feel the vibration, let them know that there is the obstacle ahead or there's some water on the floor. This is one of the most important component of our system. Project schedule and timeline. This is a phase one of our project schedule and timeline. As you can see, as of July 20th to July 27, most of the sensor calibration and testing has already been done, except the Bluetooth module. So we didn't order the Bluetooth module yet, so we haven't calibrated or tested the Bluetooth module yet. But one thing we did test the prototype one of the project on the breadboard. The prototype one only include the ultrasonic sensor and the light sensor. So he was able to make the ultrasonic sensor work and the light sensor to turn on at nighttime or turn off at daytime. And next month we'll be checking for the power consumption and hopefully connect the Bluetooth module to the prototype one and get them working. Alright, project schedule and timeline. That will be phase two of our project. So as you can see, we're already done with the power consumption by September 21st. So now we're going to start working on the 3D modeling and to measure all the components. That's why they can fit inside the enclosure we're going to use. And by the way, the enclosure will be the handle of the high stick. So by October 12, we should be able to test prototype 2 of the project. And hopefully by the beginning of November, we can start do the real world testing of the whole project. A couple of weeks later, we'll be trying to see if we can fix any bugs in the system. Hopefully we can get everything cleared out. That's why I can put the final housing on the high stick, and then we can do the final field testing, hopefully by November 30th, and hopefully we got the final working unit by the first week of December. This is the list of the tasks that need to be done, and we're going to be working on those tasks. For the design and implementation of the system sensors, including but limited to ultrasonic sensor, the moisture sensor, vibrating motors, and the alarm buzzer, light sensors, witness analysis will be working on this. For the design and implementation of the wireless communication system using the Bluetooth, Hentong and Alnodas will be working on it. And for the design for the housing unit that include all the circuits and all the components, all the team members will be working on it because we need to get different opinion. And for the design and implementation of the self-contained power system, we Cincinnati will be working on it. And for the implementation of the remote user interface, Hinton and Arnoldas will be working on it.
Thank you so much, and hope you enjoyed our presentation.